Hello grade 11s and welcome to the second part of question number 1. In this video we're going to look at questions that involve the shapes of different molecules and whether or not the entire molecule is polar or non-polar. Again, please make sure to try the questions before watching the video to see if you remember the content and if you're on the right track. So question number 1.2 says, define the term electronegativity for 2 marks. We say electronegativity is the measure of the tendency of an atom in a molecule to attract a bonding pair of electrons, right? So you have 2 atoms that are bonded together. Electronegativity tells us which atom is going to pull that bonding pair of electrons to itself, and basically where those electrons are going to spend most of their time. For writing this down from your exam guidelines, you're going to get 2 marks. So don't expand on it, just write down exactly what's on the board, or on your screen in this case. Question 1.3 says, explain the difference between a polar and a non-polar molecule. Now previously, in the previous video, we were looking at polar and non-polar bonds. Now they want the difference between polar and non-polar molecules. So we're looking at the molecule overall. You're going to see that the answer on your screen is very lengthy, but this is what you need to mention. We say a polar molecule contains charge that is unevenly distributed, and it therefore or thus forms a dipole. For writing this down, you're going to get 1 mark. You could have instead said that one end of the molecule is slightly positive, the other is slightly negative, but that's unnecessary. Then the non-polar molecule is a molecule that has evenly distributed charge, and it therefore does not form a dipole. For writing that down, you're going to get your 2nd mark. But of course, you could have instead said that it does not have poles on its end. So it does not have one side slightly negative and the other side slightly positive. So that gets you your 2 marks to question, or for question 1.3. The difference is whether we have these electrons, the charges, evenly or unevenly distributed. On to question 1.4, it says the table below shows the properties of methane and chloromethane. We see the molecular formula, CH4 for methane and CH3Cl for chloromethane. Their structures look very similar, and that is because they both have a shape called tetrahedral. But we see there's a difference. The methane molecule is non-polar, while chloromethane is polar, and that is important to take note of. Question 1.4.1 says, explain why the methane molecule is non-polar. So in order to explain this, we actually refer back to question 1.3. To answer question 1.4.1, you can simply state that the methane molecule has a symmetrical distribution of charge, and there is therefore, so for stating that there's an even distribution of charge, right, or charge is evenly distributed, you're going to get your 1st mark. Your 2nd mark will be awarded for saying there is no distinct oppositely charged poles or ends. So this molecule, CH4, does not have a slightly negative side and a slightly positive side. Okay, that is what you're getting your 2 marks for. Now we can move on to question 1.4.2. It says a chlorine atom replaces the hydrogen atom. If you look over here, there was a hydrogen atom and now it's replaced with chlorine. They say in the methane molecule so that chloromethane forms. Both molecules have the same shape. Explain why chloromethane, the chloromethane molecule that forms, is polar. So firstly, we're going to take note of the differences. See, over here between hydrogen and carbon, if we take a look at the periodic table, we're going to see carbon has a higher electronegativity than hydrogen. In fact, the electronegativity of carbon is 2,5 and that of hydrogen is 2,1. So if we look at the methane molecule, all of these arrows displaying the dipole is going to point towards carbon. But now we replace a hydrogen with a chlorine. And when we compare carbon, the electronegativity of carbon to that of chlorine, we see that chlorine has a higher electronegativity. So therefore, we have the dipole facing chlorine, and chlorine will be slightly negative, while carbon in this chlorine bond will be slightly positive. So based on this, we start off by stating chlorine is more electronegative than carbon. For stating that, we're going to get 1 mark. Previously, we had that hydrogen was less electronegative than carbon, but now we notice chlorine is more electronegative than carbon. We say this makes chlorine slightly more negative and carbon therefore slightly more positive. That's going to get us the 2nd mark. Since there is a distinct positive and negative end, we can say that the molecule is polar, or you could instead say that since the charge distribution surrounding the central carbon atom is not identical, or you can even say since the charge distribution is uneven, we can come to the conclusion that the chloromethane molecule is a polar molecule, and that is going to get us our 3rd mark. So 1 mark for stating the difference between the electronegativities of chlorine and carbon. 1 mark for saying that chlorine will be slightly more negative, and 1 mark for mentioning the uneven distribution of charge. That's going to get you your 3 marks for question 1.4.2. In grade 11s, this brings us to the end of this video. In the next video, we're going to take a look at intermolecular forces in question number 2, and we're going to see how intermolecular forces have an effect on physical properties such as boiling point. I hope to see you there.